Sections, we're going to take care of the derivative of log functions. So how do we do it? We're going to use implicit differentiation for log functions. So you can see right here, this is the derivative of log. And now if you have just ln of x, which is b is e, then the derivative is just 1 over x. Okay, so let's take a look at example 1. Keep in mind we have to do chain rule. So the outer function for this one is the ln function, and the inner is the x cube function. So first I need to take 1 over x cubed plus 1. And then I'm going to take the derivative of x cubed plus 1, which is 3x squared. Okay, so that's the answer. So make sure you take care of the chain rule. Okay, so if you want to rewrite, this would be better. Now, if we combine everything, the formula 2 to chain rule, you see that we have 1 over g of x and then g prime. So it's just g prime over g of x. So keep that in mind. I don't even think of it. I just take care of chain rule. Okay. So right here, as you can see, the outer function is going to be the ln. So I'm going to take 1 over sine of x. And then I multiply by the derivative of sine of x, which is cosine of x. So we get cosine of x over sine of x, which is just cotangent of x. Okay, so that's example 2. What we have for example 3. So you see right now the outer function, in fact, is a square root function. So I'm just going to rewrite first ln of x to the 1/2. Now, going with chain rule, what we have is 1/2 ln of x to the negative 1/2. And then you take the derivative of ln of x, which is just 1 over x. So what I have is 1 over 2 square root of ln of x times 1 over x. So if you combine it, that would be 1 over 2x square root of ln x. So that's how I simplify. Okay. All right, moving on to number 4. Now we have the base. The base is 10. So make sure we use the formula up here. This formula right here. Okay, so keep that in mind. So now what I have is, so let's just keep in mind b is 10 in this case. So what I have for f prime, the outer function is the log function in this case. So it's going to be 1 over 2 plus sine of x times ln 10, because b is 10. And then we have to take the derivative of the inside, which is 2 plus sine of x. All right, so I'm just going to rewrite this part, 2 plus sine of x ln 10, and the derivative of 2 plus sine of x is cosine of x. And there we have it. That's our final answer. So you can definitely put this on top and then put this on the bottom. Okay. All right, moving on. So you can see right here what we have is the ln for the outer function, and then the inner function, what we have right here, is going to be a quotient. So first, I'm just going to rewrite the square root. So what we have is ln of x plus 1 over square root, which is, sorry, I want to rewrite. So I want to write x minus 2 to the 1/2. Okay, now let's take care of quotient rule. So what we have is 1 over that whole thing. So it's x plus 1 over x minus 2 to the 1/2. And then I'm going to take the derivative. So now the derivative, this is what I need to do. The derivative of x plus 1 over x minus 2 to the 1/2. So this part right here is going to give me the quotient rule. So the quotient rule is, what I have is going to be 1 times x minus 2 to the 1/2 minus x plus 1, and then I take the derivative of this one, so it's 1/2, x minus 2 to the negative 1/2, and everything is going to be over to x minus 2 to the 1/2, and you square it. So here, so the 1/2, and then I have to square it. So it just cancel out. Anyway, this part right here, since you have 1 over the fraction, we're just going to do the reciprocal. So I have x minus 2 to the 1/2 over x plus 1. Okay. All right, let's just simplify it. It's too messy over here. So hopefully you can recognize that we have this one multiplied by that one is just x minus 2, right? And then we have another one. So technically we multiply the whole thing here. So I have to put the parenthesis here. So it's like distribute. Okay, so if you distribute this one with that one and this one with this one right here, a lot of things will cancel out. So what I have is x minus 2 minus 1/2 x plus 1. Okay, because the x minus 2 cancel out. All right, on the bottom, what I have is x plus 1 and x minus 2. Okay, so hopefully you recognize that. Okay, so let me point it out. So x minus 2 square root times x minus square root of x minus 2 is going to give you x minus 2 because the square root cancel out here. This one multiplied by that one is just 1. So that's why I only have this part over here. Okay, so hopefully you recognize that. Anyway, right now we're just going to simplify it. So x minus 5, and then I have 2x plus 1 and x minus 2. Okay. All right, so let's take a look at example 6. So what you have right here, what we have right here, hopefully you see that we have the absolute values. So when it's come to absolute values, you have to be careful. So what do we have? We have to take the derivative of ln of the absolute values function. Now, how do we define that? So f of x is going to be ln of x when x greater than 0. When x is positive, it's going to be negative ln of negative x when x is 0. Okay, so we're going to have to take the derivative for both. So the derivative this time is going to be 1 over x when x positive, and then we have 1 over negative x, and then you do the chain rule, so we have negative 1, which is just 1 over x as well, so when x is negative. Okay, so you see that f prime of x is going to be 1 over x for all x not 0. Okay, so the result is going to give you this one, 1 over x. Okay. All right, so just because of the chain rule, everything is going to cancel out. And of course, you don't want to include that 0 because the 0 is going to give the denominator equal to 0, which is undefined. Anyway, look at example 7. It's really, really messy. So what we need for number 7 is we have to do implicit, and we have to apply the log function because you see right here, it's just way too messy. Okay, so what do I mean by apply log? So the reason you want to apply log, so we can simplify it. So these are the steps for the log differentiation. First, you take the natural log on both sides, and then we use the laws of log to simplify it, and then we differentiate implicitly with respect to x, and then we solve for y prime. All right, so if I apply ln on both sides, square plus 1, you know what, I'm just going to rewrite and then make that to the 1/2 like this, over 3x plus 2 to the 5th power. Hopefully you remember the properties of log. So when you apply log for the whole thing, okay, you can use a product and the quotient rule. So what is the product? That would be ln, and then you can split it. So what we have right here is going to be 3/4 ln of x plus 1/2 ln x squared plus 1 minus 5 ln 3x plus 2. So hopefully you remember this. So remember, for the power, we take it to the front. The power, we take it to the front. If it's a product, we add. If it's quotient, we subtract. Okay, so that's how we do it for the law of logs. All right, now we are ready to differentiate. So if we differentiate, we're going to have 1 over y. Okay, don't forget we have 1 over y, but y we're using chain rule, so we have y prime. Now this one is going to be 3/4 1 over x. So I'm going to put x down here, plus 1/2, and then x squared plus 1. Don't forget chain rule, so I have 2x. And then minus 5 over 3x plus 2. And then chain rule, so I have 3. I have to multiply by 3 right there. All right, let's just multiply y over, you know what, we can definitely clean it up. Okay. So if I multiply y over, the y prime that I have is going to be y, and then I have 3 over 4x plus x over x squared minus 1 minus 15 over 3x plus 2. And that's my final answer for y prime. Okay, so when things get way too messy with product and quotient rule, you can always apply log. All right, now let's take a look at number 8. You see right here, this is just the power rule we pretty much just learned from the beginning right here. Now, when you have something like this function is x to the square root of x, is a function within function, so we're going to apply the log. So if I apply log, I can take the power to the front. That's the whole point of the log, because we don't want to deal with the power. All right, now we can just take care of the y prime now. So it's going to be 1 over y prime for this one. Now what we have right here is the product rule. So you apply product rule. So I have that multiplied by this plus, and I have x 1/2, x to the negative 1/2 ln of x. All right, now we're gonna simplify it. I'm gonna simplify this. It looks way too messy. The first one, you see that we have 1 over square root of x. Okay, why do I have 1 over square root of x? Because of this. So if I change it, x to the 1/2 divided by x to the 2/2, 2 over 2. So it's negative 1/2, right? So negative 1/2, which is the half is going to be on the bottom. So that's how I got it. Okay, so let's just simplify this one. Okay. So as you can see, this one I have square root 1 over square root of x plus ln 2 square root of x. Okay. All right, now I'm going to multiply y over. Okay. And don't forget y from the very beginning is x square root of x. If you want to make the LCD here, you can do it. So I'm just going to multiply this one right here by 2 to make it into LCD. So 2 plus ln of x over 2 square root of x. All right, that's going to be my solution.